All right, now that you can compose two functions for a given value or take a given value and put it into two different functions, now we want to look at what if we don't have a value? What if we simply just want to essentially squish two functions together? Well, before we do that, I want to point out some notation because everyone always mixes these up. So remember f times g, so they're written right next to each other, of x, is the same thing of f of x times g of x. Again, they're written right next to each other, so I know that's multiplication. This is from objective number 2, where you're performing operations between functions. I'm multiplying here. This second piece, however, read f following, or f of g of x. Notice that I don't have any kind of multiplication. They're not written right next to each other. We have that composition symbol in between. Same thing here. This isn't written as a multiplication problem. Up here, I'm taking the entire function f of x and multiplying it by the entire function g of x. Here, I have the function g of x plugged into f. This is very similar if I have g following f of x or g of f of x. Again, no multiplication. Again, f of x is inside of g versus taking an entire function and multiplying by another one. So there are only 2 examples here, but they are long because on each example, I look at the different ways of representing each one and differentiating between when am I making a composite function versus when am I doing multiplication. So let's go ahead and jump right into it. When we do these, the big thing we want to do is we're going to start with the inside function just like before, but now instead of plugging a value into the inside function and then plugging the result into the inside function, I'm not going to get a result or a value. So I'm going to take the inside function and put the inside function into the outside function. And then I'll always simplify if possible, or state domain restrictions if necessary. So example 1, part A, I'm finding f following g of x. The first thing, again, I do is f of g of x. I like those parentheses. It helps me clearly see order of operations. I'm going to start here. So I'm going to drop my f down, and in place of g of x, I'm going to place my x squared minus 3. So I'm going to put all of x squared minus 3 in for g of x. And now what is this telling me to do? This is telling me to go to my function f, and every time I see a variable, replace the variable with this whole expression. So this is going to become 2 times x squared minus 3 plus 3. From here I can simplify. I can go ahead and distribute the 2 and combine like terms, giving me a final result of 2x squared plus 3. So this is my new function that is a composite function of both of these functions together. You've been working on a unit question as you've been working through this. Notice that that unit question asks what happens if you take a % off and you use a coupon. It's 2 different functions. So we're really driving towards finally answering that question and coming up with a function to represent what happens when you use a coupon and a discount. But before I get more on that, do anything more with that, I want to look at part B. So part B, I notice I'm taking all of f of x and all of g of x, and they're written right next to each other. That to me means multiplication. So this is the problem, part B, is 2x plus 3 times x squared minus 3. Well, binomial times binomial, I know I FOIL. We've done a lot of foiling, so I'm not going to go through the full FOIL process. If this is something you struggle on, you should probably pause the video and go through it. But you do get a final answer of 2x cubed plus 3x squared minus 6x minus 9. I don't want to spend a lot of time on the process of it. We've all learned the process. I want to spend my time on recognizing when am I doing a composite function versus when am I doing a multiplication problem. Letter C, the last part of this example. This is very similar to letter A. Notice on letter A, I had an inside function inside of my outside function. Now I have f of x on the inside of g. So same thing, I'm going to replace f of x with f of x. So I'm going to have g of 2x plus 3. So what the heck does that mean? Well, that means go to my function g, and every variable I'm going to put 2x plus 3 in its place. So I only have one variable, so that's going to become 2x plus 3. As we've stated before, we always plug in with parentheses. Now I'm going to go ahead and recognize that I need to write this twice in FOIL. I'm not going to distribute a square. We can only distribute exponents when it's all multiplication. Because of this plus sign, because it's a binomial, not a monomial, I have to write it twice in FOIL. And I said I was going to write it twice in FOIL, and I didn't. So I'm going to edit this a little bit. There we go. Now I have 2x plus 3 times 2x plus 3 minus 3. After foiling, this becomes 4x squared plus 12x plus 9 minus 3. Combining like terms, I get a final answer of 4x squared plus 12x plus 6 for my new composite function. So notice that f of g of x and g of f of x did not give me the same result. Okay, so there is a difference between f of g of x and g of f of x. Let's go ahead and look at example 2. Example 2 is a little more difficult because I brought a fraction in, but everything's going to work the same way. So I'm going to go ahead and start on example A. So on example A, I know that g following f of x is the same thing as g of f of x. And that tells me to say, remember, I'm going to bring this over here, that tells me to plug f in for f of x, so that's going to be g of 1 over x minus 4. What does that mean? That means go to g, and every time I see a variable, plug 1 over x minus 4 in. So this is going to give me 1 over x minus 4 squared minus 2 times 1 over x minus 4 minus 8. So oftentimes this freaks students out because, oh my goodness, what do? I'm squaring like some kind of crazy fraction function. Well, the nice thing about math is all about patterns. You figure them out and then you just keep working with them. So I know that to square something means write it twice. So I'm going to do that. So I'm going to have 1 over x minus 4 times 1 over x minus 4. I can also go ahead and do this because I know when I multiply fractions, I go straight across the top. So 2 times 1 is 2. 1 times x minus 4 is x minus 4. Okay, from here, how do I multiply these? Well, I can multiply the tops and I get 1. I multiply the bottoms using FOIL and I get 1 over x squared minus 8x plus 16 minus 2 over x minus 4, all minus 8. Since this is a fraction and it has a denominator, I really should state my domain restrictions. Well, I can see from here and here that x cannot equal 4. We will move into working more with rational functions and learn how to simplify this further, but for now, that's all we need to do. And looking at part B, notice it's very similar to part A, except for now g of x is my inside function instead of f of x. So I'm going to take f of g, which was x squared minus 2x minus 8. And what does that mean? That means go to f and plug that in. So I'm going to have 1 over x squared minus 2x minus 8. I plug in with parentheses minus 4. One thing I see students do a lot is as soon as they see parentheses, they think, all I want to do is FOIL and all I want to do is multiply. But notice I put these parentheses in because as a general rule of thumb, I always plug things in with parentheses, but I don't have anything to distribute. So I now notice that those parentheses aren't necessary, so I'm just going to drop them. And in doing so, that then allows me to combine like terms. I need to state my domain. So in order to state my domain, I know that I need to figure out when the bottom is 0 because x squared minus 2x minus 12 cannot equal 0. If I try to factor this, I realize it's not factorable. So I work through my quadratic formula, and I'm not going to put that in this video. I did this as a side note in my scratch work, and I get x cannot equal 1 plus or minus square root of 13. Again, how did I get that domain? Using my quadratic formula. And that is definitely something we can talk about in class. I just don't want to spend 4 minutes of a video working on something that we've already mastered. Last example. Notice that I know that this is f times g of x. So that's the same thing, not f of g of x, f times g, because they're written right next to each other. So that's the same thing as f of x times g of x. So all I'm going to do is multiply my functions. So I'm going to take my f of x, and I'm going to multiply it by my g of x. Notice if we have a denominator and we don't write it, it's 1. So this is technically over 1. So I multiply straight across the top. and straight across the bottom. I always check to see if I can simplify. This is now a rational expression. I can see that the top factors to be x minus 6 and nope, I'm sorry, x minus 4 and x plus 2, because negative 4 times 2 is negative 8 and negative 4 plus 2 is negative 4, all over x minus 4. So my x minus 4's cancel out, leaving me with x plus 2 as long as x does not equal 4. And there's my simplified result with my domain restriction. You now have enough information to go ahead and finish that Unit 8 question. Once you finish it up, please make sure to sit down and talk with me or a peer about what you get so we can make sure that you have all the correct steps. And then there will be a worksheet that goes over this piece of objective number 3, but also brings in some components from 1, 2, and 3 to get you ready for that quiz on objectives 1 through 3.